Very good morning to all of you students. Welcome to the physics class. In this section, we will study the rest part of the chapter 12, alternating current. As in the previous lecture, in two parts of this chapter, we discussed the whole description about the chapter, and in the first two part, we will discuss some important topics, and this is the last part of this chapter. And in this lecture, we will discuss and complete the whole chapter with numericals also. So student, see this lecture very carefully, because in this lecture we will discuss two important points and two important topics. First is alternating current generator and second one is transformer, and these are very important according to your board syllabus. So start student. So first topic is alternating current generator. It is also known as AC dynamo. So a device which is used to convert mechanical energy into electrical energy is called an electric generator. This is the proper definition of electric generator. Now what on which principle it works? So the principle of electric generator is when a closed coil is rotated rapidly in a strong magnetic field, then the number of magnetic flux lines passing through the coil changes continuously, and the EMF is induced in the coil, and the current is also flows in this coil in the direction gives the Fleming's right hand rule. That means with the help of AC dynamo we can find the electric current and we can convert current, alternating current, with the help of a generator. Clear? Okay. Now the circuit diagram, the diagram and the parts of the AC generator is given in the diagram. As you see that in the diagram there are main 5 parts. So we will discuss here construction and working of AC generator. So there are the main 5 parts of AC generator. First is armature. Armature means coil. So in the diagram you can see here ABCD is a coil which is made by the copper, and this is known as armature, and it is placed initially horizontally, and this is connected with the help of a source, or you can say that it is a circuit. Now the next part is field magnet. There are two strong horseshoe type magnets given N and S, which produce and which generate a strong magnetic field by which we can rotate the coil placed between these two magnets. Okay, now the third one is slip rings. There are two rings R1 and R2 are connected with the wire, and these wires are connected with the coil. That means the coil is indirectly connected with two rings, and they are slips because they can be slipped when the coil is rotating. That's why they are called slip rings. Now the next one is brushes. The two carbon brushes are used which are just touch the ring, and when the ring is slipped, that means the circuit is rotating, then the brush only touch it, and they are made by the carbon. So they are insulator but provide the electric current. Clear? Now what is the working of electric generator? So we will discuss here very clearly. As the armature, that means coil ABCD, rotates, the magnetic flux linked with it changes. That means when coil is rotating, then the magnetic flux also changing, which is linked with the coil. Hence an EMF is induced, that is produced in the coil, and the current flows in it. Suppose in the initially the coil is rotating clockwise direction and is horizontally at the same instant of time, then when the coil is rotating, so in the first half of the cycle of a coil we get the maximum value of alternating voltage and alternating current in upward direction, and when the coil rotate in downward direction, then we get the maximum value of alternating voltage or current in downward direction. That means in the complete half cycle we get 1 times maximum voltage or current in upward direction, and the next half cycle we get the maximum value of alternating voltage or current in downward direction, and by the rotating again and again with the help of strong magnets and source, a bulb which is connected in the circuit is blowing. That means we can see that an alternating current is produced by rotating the coil. So we can say that this coil is work as a generator, because we know that generator is generally used to produce electric current, and here we produce alternating current. So this generator, which is made by rotating the coils, is called alternating generator. Clear? This is the working and construction of alternating current generator. Now student, the next important topic is transformer. Transformer is a device based on the principle of mutual induction. That means in mutual induction there should be two coils take place, and in the case of self induction only one coil is present, which is used by converting large alternating current at low voltage into small current at high voltage. So on the basis of this, transformer are of two types. First, step up transformer, and second one is step down transformer. So what is the construction of transformer and what is the theory of transformer, we will discuss both by the diagram. So you can see here there is a diagram of transformer, and in the transformer you can see here AC mains, that means a AC source is connected with primary coil, and there is a core of insulated copper wire, and it is also known as laminated core. Now, the secondary coil contain a number of turns in the compare of primary coil. That's why this is called step-up transformer. Now, we will discuss what is the difference between step-up and step-down transformer. First one, step-up transformer used to produce high voltage from low voltage. That means in order to increase the capacity intensity of alternating voltage and current, we use step up transformer, and in order to reduce the capacity and the strength of alternating voltage or alternating current, we use step down transformer. So in the case of step down, we decrease the capacity or voltage or power of alternating current, and in the step up transformer we increase it. Clear? Now in the case of step up transformer, in primary coil the number of turns are very low, very few, and in the case of secondary coil the number of turns are almost just double of the primary coil, and in the secondary coil we use thin wire, but in the case of primary coil we use thick wire. Now in the case of step down transformer, the number of turns in the primary coils are just double to the number of turns of the secondary coil, but they are made by the thin wire in the compare of secondary coil. Clear? So these are the basic differences between step up transformer and step down transformer. Now as you know that, now we will discuss here the theory of transformer. Now as we know that according to Faraday's law of electromagnetic induction, the EMF EP produced in primary coil will be equal to NP delta phi B upon delta T, where NP is the number of turns in the primary coil and delta phi B upon delta T is the change in magnetic flux. Clear? In the same way, we can also find the value for secondary coil. It will be ES is equal to minus NS delta phi B upon delta T. When we divide both two equations, we get ES upon EP will be equal to NS upon NP. That means the ratio of EMF produced in secondary coil to the primary coil will be equal to the number of turns in the secondary coil to the primary coil. Now we can also write here Vs upon Vp is equal to Es upon Ep is equal to Ns upon Np, and they all are equal in ratios and they will be equal to small r. A small r is known as transformation ratio, and in step up transformer small r is more than 1, while in step down transformer it will be less than 1. Clear? Okay, student. From the above formula, we can also find the power in secondary coil. So power in secondary coil will be equal to power in primary coil. So here we can see Vs into Is is equal to Vp into Ip. Then Ip upon Is is equal to Vs upon Vp is equal to Ns upon Np will be equal to small r. Clear? Now students, energy losses in transformer. So as we know that transformer is used for the transformation of energy from powerhouse to our houses. So there are some losses of energy take place in the transformer, and they are as given. First, copper loss. So what is copper loss? As the alternating current flows through the primary and the secondary, heat is developed inside the copper turns. This wastage of energy is known as copper loss, because generally copper wire is used in the transformer. So the wastage of energy is known as copper loss. Now, eddy current losses. Eddy currents are set up in the iron core of the transformer and generate heat with consequent loss of energy. To minimize these losses, the iron core is laminated with making it of a number of thin sheets of iron insulated from each other instead of making it from one solid piece of iron. Such type of losses is known as eddy current losses. Clear? Now student, hysteresis loss. This is important and generally asked in the board examination. During each cycle of AC, the core is taken through a complete cycle of magnetization. The energy expended in this process is finally converted into heat and is therefore wastage. This loss is minimized by using the core of a magnetic alloy for which the area of hysteresis loop is minimum. That means we can reduce this loss by making the hysteresis curve very minimum. Clear? Now, flux losses. The coupling of the primary and the secondary coil is never perfect. Therefore, whole of the magnetic flux generated in the primary does not pass through the secondary. It means that we can see here Vs into Is is less than Vp into Ip. That means the transformation efficiency eta is equal to Vs into Is upon Vp into Ip. So which is less than 1, not 100%. That means flux losses are also take place in the transformation. Clear? Okay student. So these are the important 2 points and 2 topics. First one is generator and second one is transformer, and both are important. That's why I form another special video for you, and in this video you discuss what is the construction, working, parts, importance, disadvantage of these two. Clear student? So revise these two topics very well, because both are very important and generally asked in the board examination as a long question. Okay, thank you very much.